Marty Fabry is the Vice President of Field Services and Operations at Zentera Systems. Not only is Mr. Fabry a business leader, but he also has hands-on field experience in building out and operationalizing zero trust solutions for large enterprises. At Zentera Systems, Marty has tackled diverse use case scenarios and large-scale challenges across companies with complex global operations. Prior to Zentera, he was co-founder of IoT data processing startup and field-facing engineering leader at a network and security processor manufacturer. So go ahead, Marty, and thanks for presenting.
Thank you, Rhonda. Give me a moment to set up here. All right, thank you very much for the introduction. As Rhonda mentioned, I'm Marty. I lead the field services and solution engineering at Zentera. And my talk today is going to be in the context of our secluded semiconductor case study. And I will talk to you about our vision and technology, how Zentera overlays our ideas and a platform to solving this case study here. So just briefly, I'm going to structure this first by reviewing what is the secluded semi environment. What are the challenges? What is it we are trying to solve? Then I'll at high level touch on the objectives and the vision of Zentera's solution. Then I will overlay that and map it to the use case, to the secluded semiconductor environment, and discuss the various components and configurations that need to be considered there. And then also, Rhonda and Tim and team had prepared a series of questions that they wanted us to sort of chew on and discuss at a little bit sort of a deeper level. So I have a section about some of those questions, and then we'll try to leave some time for Q&A. So let me start with the diagram of the secluded semiconductor, and you may have seen this from some of the other talks. To level set here, we've got an environment which is pretty complex. There is the upper section here, which is on the continental US, and there is an environment which is situated on a secluded island. And these consist of multiple networks, multiple sites. Some of them are, the HQ may be on a physical on-prem environment. There is a public cloud component. And of course, the factory, being on a remote island, has its own set of resources, both some sort of a local data center, as well as an operational technology, a factory floor, with its own industrial IoT, data collection, and interesting aspects from there. So clearly, this is a very complex environment. There are a lot of perimeters from the traditional perspective of network architecture. There are lots of different types of technologies. The security, the networking and operation and the security stacks are probably very diverse in each of these locations. They have probably been managed by multiple different departments over time. And as one of the commenters had mentioned, they may or may not have sort of communicated or may be at different levels of collaboration. So the challenges are not just technical, but of course also organizational, structural. And with these challenges, we need to consider some of the legacy approaches to communications have required opening up networks, connecting things before securing them. So these are some of the real challenges. Of course, the secluded semi is a fictional company, but the problems here are pretty real. The one specific point here is that the communications between these between the continental U.S. operation and the factory operations on the remote island are connected through satellite links, which will, as we'll see, are subject to issues. So I'll leave that picture for a moment and talk a little bit about Zentera, our vision, our platform. Our approach, our classification of the different tools and problem statements that we are here to address. One of the original or sort of continued requirements and technologies that needs to be solved is the segmentation at a logical level, which we refer to as virtual chambers. There may be machineries, resources that are logically interoperating. They may be part of the same job function, but they may be geographically distributed. So network zone segmentation from the legacy perspective may not necessarily apply once you're going into hybrid environments. Our virtual chambers focus on this sort of underlay agnostic deployments. Microsegmentation is basically taking the network zone segmentation to the next level, really reducing those perimeters. In the speak of the NIST 800-207, we're really minimizing those intrinsic trust zones. The access control, of course, is required whenever we try to put something on an island, no pun intended. It's not just a matter of locking it down or blocking it from talking to the rest of the world. We actually need to enable communications with that, whether it's from other machines or from users. So when we're talking about users, that's referred to as ZTNA. And those connections have to be able to come from either local environment, remote networks, or external to our private network boundaries. Last but not least, we also have the capability to set up overlay application networks. These are very useful when we have different organizations that need to connect resources, unconnected networks, things that VPNs are simply just not necessarily good or fast at, or we want to do it with the much narrower scope in mind. We don't want to connect networks, we want to connect applications in a very narrow manner. So these are different types of engines, if you will, in our platform. And as may be becoming apparent, we actually are agnostic to what environment we are deployed in. Assuming that it's an IP network, we can deploy in environments irrespective of what architecture they have, whether they have what security level or segmentation there may exist already. So we deploy relatively easily within IT, OT, or cloud environments. A little bit more about us. So it's very critical that when we are working with someone to deploy the zero trust, the new architecture, the new objectives into an existing environment, that we not only provide the components to install and set up such that it can be managed. It's also very critical that the environment, the architecture, allows for easy operational management. And with that comes policy. One of the biggest, one of the most critical aspects of that is policy management. Those policies, when we work with our customers, it is absolutely useful, absolutely critical that these policies are simple, high level, that an operator or the person taking care of an IT ticket to deploy a particular, to enable a particular policy, does not have to worry about the implementation details. Which are all the different components in the network that it touches? Does it cross multiple sites? So these policies at a very high level must be simple. And of course, they must be strong in their security sense, that they must be based on strong user identity, application identity. When we are actually enabling the policies, which often gets orchestrated on demand, they are subject to various security checks, such as security posture. The diagram below here simply helps map our technology, our platform, to the NIST 800-207 speak. So from its original inception, our platform separates the control plane and data plane. With the terminology of the PDP, which is policy decision point, that's what we call our Z center. That's basically the brain of the operation, where the policies are managed, but also where the orchestration takes place at the time of establishing communications. We also have the various data plane components, including the PEPs, which are policy enforcement points, and they get deployed in various places, as I'll talk to on the next slide. So let's go back to our picture of the secluded semiconductor environments. And let's start off talking about the components. Let's say we want to take this existing brownfield, this existing set of sites, and we want to bring them to the zero trust world. What are all the different steps that we need to take to get there? What is the journey? So one of the critical steps is deploying our the infrastructural components, if you will, the PDPs, the policy decision points, which I mentioned we call Z centers, and those generally we guide to install with regional redundancy or replication, such that if there is potential for intermittent connectivity, they can continue to function, which is, of course, critical in this environment here. We also have something we call the ZNS, Zentera Network Switches. These are appliances that facilitate the data path. The data path can be placed, the data path connections can take place in all sorts of directions here. So we generally distribute those to optimize the data path routing and so on. Once we have our basic appliances and the capabilities of the architecture in place, the next step is to deploy our components that enable the different resources to participate, to be onboarded to the COIP platform, which is the COIP platform is the name of our product. So these little icons with the chained links, those are basically agents. We deploy most quickly and most securely with agents wherever they can be deployed. That makes it quick, it makes it agile, and it allows us to deploy all sorts of resources and any sort of modern resources, especially on the IT side, with very quick time to deploy. In the OT space, there definitely exist appliances or equipment, factory equipment that will not be able to install an agent for all the good reasons. There may be closed appliances managed by third parties. They may be a legacy or closed or unpatchable, and we'll talk a little bit more about that. So in these cases, we have a component which we call MSG, which stands for Microsegmentation Gatekeeper. The Microsegmentation Gatekeeper is pretty much an extraction of the functionality of the agent, and it is simply placed in front of this equipment. It services most of the capability of the agents, except it now sits as a sort of a transparent insertion point in front of that appliance or in front of that factory equipment. Now, of course, there are users. For those, we have launchers. Users must authenticate. They must have a dashboard with a list of authorized resources from which they can start their connectivity and daily jobs. So those are labeled with these little icons with the users. So now, once we have all the components deployed, then we can start setting up these chambers. As I mentioned before, virtual chambers are our concept of basically policy boundaries, logical boundaries of which servers or equipment participate in for whatever the network communications are necessary. These virtual chambers can be logically assigned to arbitrary groups of servers or machinery. They can be with or without agents. And they can even be across geographically distributed sites. And once we have all of those in place, then we can start talking about data flows, communication paths, access. So whatever we've done so far is really to enable us to control access. In an environment like the secluded semiconductors, we are going to probably see communications or access paths that are going to be of all sorts, whether they are users to machines, maybe to cloud, maybe users on-prem in the headquarters talking to the factory floor, potentially even an external vendor that requires time-limited narrow access to help come and maintain some equipment. There are, of course, also machine-to-machine connections. With machine-to-machine connectivity, there are slightly different types of considerations. They may have to be always on, yet they have to be mutually authenticated. They have to be trusted. And of course, they're bound to cross some of those boundaries, those segments that may have been in place for some time. Hopefully, there have been some segments in place for some time. All right, so next comes the challenge of the scenario. We have a hurricane that passes through the island, and we lose communications. It goes either into reduced communications, it may back up to public internet, it may become intermittent, or it may be completely isolated. Similarly, as part of the scenario, there may be power loss or power reduction, which is presumably impacting the operation of the factory, presumably reducing the capacity of the factory or the factory output. Now, with all these challenges, our challenge is to design the system such that the operation impact is minimized, and just as importantly, the security impact of this reduced operation is not affected. So just because somebody can perhaps not run a particular equipment doesn't mean that they should be able, that somebody else should be able to break into another server. All right, so I'll tackle some of these individual questions that have been raised from the scenario by the SEI team at a little bit more depth. So first question that was posed was what mitigations would reduce the resulting security and resilience risks and threats associated with the island infrastructure. So I think first order of business is that we have our redundancy in the most critical aspects of our infrastructure. In the context of the Zero Trust system, it is the PDPs. The PDPs are what govern the security of the secure microsegmentation and the secure access, the ZTNA. So those must be deployed with the continuity in mind. And there is there is a whole series of resources, whether they're network resources, infrastructure resources, IT services, that also must be considered that must be designed with redundancy and replication in place. The dependency on the continental US must be built in from the start. That has to happen before the disaster incident. And if done properly, it can allow the communications and the security and the reduced operation to continue unaffected. There is one aspect that is very specific to OT environments, especially with the safety considerations and objectives in OT. Some equipment must be designed to fail open, as it's called, where there is a little bit of a trade-off between safety and security in case the communications or in case the power is completely cut off, or only some of the equipment is running on backup power. It is important that that equipment continues to function, continues to be still in control of the local operators, as opposed to only subject to some security measures that have been designed for the normal mode of operation. So this fail-open capability is something that the system designers must be carefully choosing where to place and applying it appropriately. Next question here. What concerns do legacy systems create, and how would the legacy systems be addressed to support the Zero Trust strategy? So legacy systems pose all sorts of challenges, and I'll probably only be able to touch on some of them here. Legacy systems may be outdated, unpatchable. They may have old operating systems that do not support modern security endpoint tools, endpoint protection tools. They may not be accessible, or they may not be movable, so to say, in terms of modern network security measures. So what can we do about all these different types of legacy issues, or issues that arise from having these legacy systems? So Zentera provides a few options, a few tools for handling such scenarios, and I'll go through a couple of them here. In some environments, microsegmentation can be a very effective way of securing legacy systems. Instead of trying to beat our heads against the wall, of trying to patch an old system or trying to make it more secure intrinsically, maybe it's easier or faster or simply quite the only feasible option to isolate it through the means of microsegmentation. So, for example, for an old operating system, it may not be possible to increase its software stack, but it may be possible to install an agent, a thin microsegmentation agent, that allows us to really protect the communications from that machine. We'll talk a little bit about that in a bit as well. Now, of course, for some legacy appliances or closed appliances, we have the microsegmentation gatekeeper, which sits in front of those legacy systems, and introduce the microsegmentation protections through that means. Beside microsegmentation, there is another potential strategy that can be applied, and that's encrypting the communications that still need to continue to take place from these legacy systems to the rest of the network, or to the rest to very specific servers on the other side, or applications that they need to communicate with. So perhaps what we can do is we can take those communications, and maybe those are outdated SMB protocols. Maybe there are FTP services that simply should not be there, but they continue to exist. Well, maybe we can leave them in their vulnerable state because we don't have an option to change them, but we can wrap them, so to say, in encrypted tunnels. We can encrypt our traffic, and we can pass it through LAN. We can also go over WAN, over that public internet. That's our backup means of communication with the continental US. And by the virtue of encrypted overlay, we can help isolate and protect those vulnerable systems and their traffic. Next question. What challenges arise with OT and IIoT systems when considering zero trust implementation? How do you resolve these challenges? So with OT environments and industrial IoT, we're often dealing with third-party equipment, tools, closed appliances, and there we have to consider what I mentioned, the microsegmentation gatekeepers, the MSG appliances, which come in all sorts of forms or form factors rather that can help fit into different environments. With these microsegmentation gatekeepers, we can build these zero trust DMZs. Zero trust DMZs, akin to the Purdue model of the OT environments, can simply isolate not just at a segment level or a level of the Purdue model, but really individual appliances as well. So far more fine-grained protection boundaries. And with the challenges of the OT environment is actually crossing the IT-OT boundary. Those are really big headaches, not only because they come from different environments, but they're crossing multiple of these boundaries, traditional segmentation boundaries. And with the IT to OT connectivity, having high-level policies like I discussed earlier, where we defined point-to-point communications that come, let's say, from one aggregation server from cloud or management server in the cloud to one specific machine that's deep in the OT environment. The operator, the administrator, does not have to worry about all the complexity of the underlying network. It is a single high-level policy that gets implemented by the platform and abstracts the policy simplicity. It makes the policy simple. Here I have a little bit more information about the microsegmentation gatekeeper. I think I've covered a lot of the points here. Some of the critical aspects are that these have to be transparent to the OT equipment. Minimizing latency, minimizing the layer 2 communications, or being completely transparent as far as the layer 2 communications go. That's a challenge in the OT. And even plugging it in before applying any policies has to be absolutely seamless. So maybe we plug in a cable, the equipment is back to connected, but it continues to function as expected. And from there, we can learn and apply policies based on the visibility of the traffic which this appliance gives us. One other important point is that these facilities, just like what I described before with our agents, provide the ability for users or machines from elsewhere in our network to connect directly into our equipment. So whether those connections are coming into a controller for the robot arm, they are very narrow policies. So only a particular user, only a particular application, talking only to a particular controller, without the ability then to further proliferate laterally going east-west. So these gatekeepers provide both north-south as well as east-west protections, microsegmentations, as well as connectivity, ZTNA type of capabilities. Next question. In a highly connected system like a smart city, how do you handle threats and vulnerabilities with a zero trust implementation without impacting overall functionality. So I think it goes without saying that whenever we can, we should be applying zero trust capabilities. We should be installing agents and having the users and machines become part of the platform such that they have to authenticate, that they have to be subject to authorized policies. And of course, we want to apply the least privilege principles for providing that access. Now, while that is great, of course, with highly distributed and dispersed smart cities, there will be cases where some of the technologies take time to bring to the zero trust. Many users or machines, embedded clients that may simply take a long time to bring up to the zero trust level. Well, in that case, we still need to worry about security, and there are things that we can apply. For example, in the world of, let's say, multi-tier web services or data services, there are standard techniques for protecting those services, such as firewalls and WAFs. But there are also some measures that we can take, that we can apply on the back end. With the ability to microsegment the different stages of our multi-tier service, we can protect it with the zero trust principles in mind. So for example, if there is a zero-day exploit and somebody does land on the business application layer of that web service, perhaps they can affect the operation of that one component, but they cannot necessarily simply jump onto the next component in that web service or proliferate to the rest of the network where that web server sits. So these are some good methods and techniques to apply. The next question, how does zero trust help address the accessibility and availability required of a manufacturing environment? So I think the critical consideration is the compartmentalization, the reduction of the exposed surfaces, the minimization of the trust zones in the speak of the 802.07, such that no system is completely impervious to an attack. If one is compromised, we make it very hard for the attacker to proliferate and give ourselves security boundaries. The principles of least privilege must be applied such that even if somebody's credentials are stolen, they are limited in terms of what they can do. And there are, of course, the general techniques and practices, for example, patching systems. Well, we know those things take time. There are practical considerations, the IT operational considerations that we would love to be able to patch within minutes, within hours of availability of a new patch, but we know it's not necessarily always quick or possible. So having those minimized perimeters gives us a little bit of a breathing room and considering where to patch first, not just from the perspective of which systems are most vulnerable, but also which are probably most likely exposed. Next question, what factors must be considered when managing disasters with a zero trust implementation? So I think the primary theme in this scenario is the intermittency of the connectivity. So we absolutely must reduce the dependencies, the IT services, the network infrastructural services, that has to be built into the original architecture. And the failover capabilities must be in place and tested. So those are sort of the standard preparations for any disaster. And specific to the zero trust considerations, we are talking about having redundancy in the PDPs. with the Zentera. We also have the ZNS, Zentera network switches, which facilitate with some of the network, the data plane traffic. For these appliances, basically, they have to be deployed with redundancy in mind. We already discussed the fail open versus fail closed. Do we prioritize confidentiality versus availability in the OT context, safety? So those are very critical factors to consider. As is always true, we must always consider our logging, not just our normal mode of operation, access logging and component status logging, but also the backup data paths and data and the components that are involved when we are in that disaster recovery solution. All those have to be considered from the logging and forensics perspective. All right, in the event of a loss of connectivity with cloud services, how do you manage identity and access management? So fundamentally, we still need to worry about redundancy. There are redundancy considerations that IAM and ICAM providers generally also deploy with. These may be third-party tools, and we have the ability to integrate with these through the typical SAML and Active Directory and OIDC type of interfaces. Well, if those IAM services are deployed, those should be deployed with the redundancy in mind. So, for example, there may need to be a service mirror in our distributed regions. And with our platform, we support multiple IDPs. We support going to multiple sources of authorization. So those should be able to integrate seamlessly. We do not want any single point of failure, whether it's on PDP or the systems that the PDP may be dependent on, such as the authorization, the IAM. With respect to the access rights, the C of the ICAM, or the access of the ICAM, access rights are managed with our platform in the PDP. They may be imported and they may be integrated through automation, but ultimately they are managed or they reside within the PDPs, the Z centers. So as long as we build in sufficient redundancy for our PDPs, the access management, the redundancy of the access management is built in. All right, so some final considerations that relate to both the secluded semiconductors as well as the zero trust deployment in general. So one topic, one theme that has surfaced throughout this event has been the integration, and this is something I have to echo. The zero trust maturity models discuss pillars, they discuss different technologies, and being able to grow them and advance their capabilities over time. So not only is it important to be able to deploy them seamlessly, they must be integrated. They must be able to pull in the same direction. There are integration points that are already well defined, SAML being a simple example, and those make sense. Now there are some points that may be more difficult to integrate, and I think some of this is still continue to evolve. With our vision, with our technology, we consider the microsegmentation and the ZTNA or access management in general to be very closely related, where they not only need to be integrated at vendor to vendor, but in our view, they need to be part of the same solution. Simply put, microsegmentation and ZTNA and machine-to-machine access, they all intend to control the access to a particular resource. We lock the resource down, and then start whitelisting and enabling communications to it, whether it's from peer servers, factory equipment, or from users that are somewhere far remote. Because those are all access controls ultimately, that's one area that the integration is very critical and probably better be under a single hood. One of our a common theme when discussing with our customers when going into new environments is how to deploy, how to take on that journey of adopting zero trust or growing our security layers. And we generally recommend the inside out approach. Start small, identify your critical initial assets and data that need to be protected, that perhaps have the small exposure or scope in terms of organizational exposure, and start small. Solve that problem, knowing that it can be applied to others. Go through your learning curves, and it's not just a learning curve in terms of how to architect it, but just as importantly, how to operate. The IT operation and OT operation is very critical. So inevitably, that's a learning curve, and then scale from there to other servers, resources, and data sources. Last but not least, we offer overlay network capabilities, as I mentioned earlier, and these can help solve all sorts of interesting cases that we're faced with on a regular basis. We have the capability to, perhaps one corporation or enterprise or environment could depend on existing network that's in place, but like in the case of the satellite links going down in the secluded island, perhaps our backup plan is to go over public internet. Well, if architected correctly, that may be just fine from a security stance. And with the advent of overlay networks, it may be actually also very simple. So having overlay communications allows us to introduce connectivity between unconnected networks, far remote networks, disconnected resources, and very simple high-level policies deployed very quickly help us connect those resources. There's one other aspect of overlay networks. We offer service insertion for various third-party capabilities, such as content scanning, DLP, data leak prevention, threat analysis, various other tools that we don't do, and this goes back to the multiple pillars of the technology stack. No single vendor can do it all, and we need to enable this integration and collaboration. So the service insertion is an interesting aspect that allows us to interoperate and continue to scale out our ZT deployment. So with that, if there are any questions.
We do have a question in the Q&A. It asks, are you using software-defined networking?
So we are not an SD-WAN solution, if that's what it touches on. We are a software-driven, software-defined technology. So for example, our agents and the policies that get deployed are all software-driven, and they are agnostic to the underlying infrastructure or network capabilities. So, we like to say that we are software-defined security because of the benefits of being able to deploy very, very quickly. So hopefully that answers the question.
If there's no more questions, thanks, Marty. Thanks for applying your technology to our scenario questions too. And talking about your approaches with starting this zero trust journey with your customers, because I'm sure that's a question that comes up a lot.